A desk, a laptop already open, a notebook with the day's first task written down hours ago, a cup that's gone lukewarm. Everything is ready. Nothing is missing. And still, the foot won't lift, the chair won't pull in. The first action that should be obvious refuses to happen. This isn't the moment of being overwhelmed. This is the moment before. If that moment feels familiar, this video is about exactly that. A desk, a laptop already open, a notebook with the day's first task written down hours ago, a cup that's gone lukewarm. Everything is ready, nothing is missing, and still, the foot won't lift, the chair won't pull in. The first action that should be obvious refuses to happen. This isn't the moment of being overwhelmed. This is the moment before. If that moment feels familiar, this video is about exactly that. The Adult ADHD Center, in their 2025 framework, identifies three distinct forms. Task paralysis. A single specific action won't initiate, even when its steps are clear. Choice paralysis. The freeze happens between options, before any action can be selected. Mental paralysis. The entire stream of thought stalls. Not even thinking forward feels possible. Three different doors, three different locks. Each requires recognizing which kind of paralysis is currently running before any tool can be applied. To understand paralysis, the most useful framework comes from Porges. His polyvagal theory, finalized in 2011, maps the autonomic nervous system into three layered states. The top layer, safe, social, engaged. The middle layer, fight or flight, mobilized for action. And the bottom layer, freeze. Freeze is the oldest of the three, evolutionarily. It predates the mammalian nervous system, and it's the one most closely linked to what gets called paralysis. Recognizing that paralysis lives in the body's oldest defense system reframes the entire problem. Freeze isn't a malfunction. It's an ancient survival strategy that worked extremely well for a long time. A deer in a clearing, a predator nearby. Movement signals presence. Stillness signals invisibility. The deer's nervous system makes the calculation in milliseconds. Don't move. The same circuit, in modern humans, sometimes fires when the perceived threat isn't a predator. It's a deadline, a difficult conversation, an inbox. The wiring doesn't know the difference. Useful in the right place. Catastrophically misapplied in the wrong one. Paralysis and procrastination get confused constantly, and they shouldn't be. Sirois and Tosti, in 2012, mapped the difference cleanly. Procrastination is active. The task is being pushed away in favor of something else, usually something more immediately rewarding. The procrastinator is doing something. Paralysis is different. The task isn't being pushed away. The task is sitting right there, ringed in ice. Nothing replaces it. Nothing diverts attention. The body simply can't move toward it. The strategies that work for procrastination, willpower, accountability, deadlines, often make paralysis worse, not better. Paralysis is also distinct from waiting mode, the topic of a previous video on this channel. Tuckman's 2022 framing helps separate them. Waiting mode is anchored to a future event. The brain refuses to engage with the present because something is pending. Once the pending event passes, the engagement can return. Paralysis isn't anchored to anything specific. It can happen with no appointment in sight. The wall and the clock look similar from the outside. Inside the body, they're built from different materials. Paralysis is a body event before it's a head event. Four physical markers, mapped by recent clinical reporting, tend to appear together. Shallow breath, locked in the upper chest. Heavy limbs, a leaden quality to the arms. Soft knees, a sense that standing requires more force than usual. Narrowed vision, a tunnel quality where the peripheral world recedes. None of these are imagined. They're measurable autonomic shifts, and they explain why instructing the brain to just start rarely works. The starting equipment isn't currently online, which leads to the question nearly everyone in paralysis has asked themselves. Why can't I just start? The answer isn't motivational. The answer is anatomical. To understand it properly means looking inside the brain itself, at the regions involved when an action moves from intention into reality. Three brain regions sit at the heart of action initiation. The anterior cingulate cortex, or ACC, the front area structure that fires the start signal. The striatum, the deep midbrain region that converts intention into motor output. And the insula, the side area structure that monitors the body's internal state and signals when conditions are right for action. Norman's 2016 imaging work on ADHD adults found measurably different activation patterns across all three regions during initiation tasks. Not absence of activity, different timing, different signal strength. The anterior cingulate cortex deserves a closer look. Bush and colleagues' 2005 work established it as the brain's start signal generator. When a task is recognized and ready, the ACC fires the equivalent of a starting pistol, and the body's motor systems move. In ADHD, the start signal still fires. It just fires more quietly. The signal is there. The motor systems don't always hear it. The result, from the inside, is that the intention is fully present, the body is fully ready, and the connection between them stays muffled. Why does the start signal arrive muffled? The most consistent finding across imaging studies points to dopamine. Volkow's 2009 work, referenced earlier in the series, shows lower baseline dopamine availability in ADHD reward and motor pathways. The bridge between wanting and doing is built from dopamine. When the supply runs thin, the bridge has gaps. The wanting is still on one side. The doing is still on the other side. Between them, a canyon. Standing on either edge, both points are visible. Crossing is the part that doesn't happen. An earlier video on this channel, The Dopamine Bridge, went through this concept in detail. The bridge isn't metaphorical. It's a real neural pathway, dependent on real neurotransmitter availability. In paralysis, the bridge is still there. The traffic just isn't moving. For the full breakdown of how the bridge works and why it sometimes stalls, that earlier video covers the ground. This video continues from where that one ends. Beyond individual regions, neuroscience increasingly studies networks. Cortese and colleagues' 2012 meta-analysis identified what's now called the task initiation network, a coordinated set of regions that have to fire together for a new action to begin. In ADHD, the network shows up consistently as undercoupled. The nodes are present. The connections between them are weaker. Some nodes fire brightly. Others stay dim. Some sparks make it across. Others don't. The result, observable from the inside, is the experience of paralysis, ready in pieces, not ready as a whole, which finally explains why the most common advice, just start, so often makes paralysis worse rather than better. Barkley's work on executive function, summarized in his 2015 handbook, is unambiguous. Initiation is not under conscious volitional control in the way most people assume. It's a system that gets triggered, not a button that gets pushed. When the system is in freeze, the conscious instruction to start meets a locked switch. Pressing harder doesn't unlock it. Different approaches do. And those approaches don't run through willpower. What does trigger the freeze then? The most common precondition, by a wide margin, stimulus overload. Recent clinical reporting consistently identifies high stimulus density as the most reliable paralysis trigger. Too many open browser tabs, a loud environment, a cluttered desk, multiple unanswered messages visible at once. The funnel narrows under the load. Below a certain threshold, no clear thread can pass through. The system isn't deciding not to act. The system can't find a single coherent action to initiate. Reducing stimulus often unlocks what willpower couldn't. The second precondition is perfectionism. Strohmeier and colleagues in 2016 examined the overlap between adult ADHD and perfectionistic traits, and the overlap is substantial. The mechanism: when an action has to be done correctly, the comparison step never finishes. Every option still has a flaw. The wall of perfectly aligned squares is the goal. The single offset square is the entire system seizing on a small imperfection and freezing on it. Lowering the standard from right to started is sometimes the only way through. So if willpower won't unlock the switch, and the standard advice often makes things worse, what does work? The answer is in the body before it's in the head. The crack in the ice doesn't form from above, by force of will. It forms from below, from the small upward pressure of physiology meeting the surface. 3, 2, 1. A protocol short enough to remember inside paralysis itself when nothing else holds. 3 senses. The body comes back into the room. 2 movements. The body tips forward. 1 minute. The smallest possible action, taken regardless of whether it feels meaningful. The whole sequence runs in under 5 minutes. It doesn't promise productivity. It promises movement, the smallest crack in the ice that the rest of the day can build on. Step 3. Sensory anchor. The simplest grounding sequence in trauma-informed psychology. 3 things visible in the room, 3 things audible, 3 things touchable, each named, even if only inside one's own head. The mechanism is direct. Paralysis is a parasympathetic shutdown, and grounding cues the parasympathetic system back into orientation. The eye, the ear, the hand, each one a small message to the body. The room is here. The room is safe. The freeze doesn't need to keep running. Step 2. 2 movements. Body forward, breath through. Embodiment research has been steady on this point. The freeze state is partly maintained by postural collapse. Sitting back, shoulders rolled, breath in the chest. The 2 movements interrupt that pattern at the lowest possible cost. Sit forward by an inch. Take 1 slow breath through pursed lips. That's it. 2 movements that the freeze can't quite block. Once they happen, the body has switched, slightly, from passive to active. The rest of the protocol can build on that switch. Step 1. 1 minute. The smallest possible action that still counts as having started. B.J. Fogg, in 2019, called these tiny habits, and his evidence was straightforward. When the action is small enough, the system can execute it even when it's depleted. Open the document and stop there if needed. Type 1 sentence and stop there if needed. Pull on the running shoes and stop there if needed. The point isn't completing the task. The point is creating the first crack. Continuation, if it comes for free. And when the protocol on its own isn't enough, body doubling, the presence of another person working nearby, real life, video call, or a body doubling video like the ones on this channel. CHAD's resources have documented body doubling as one of the most reliably effective interventions for ADHD initiation problems. The mechanism, again, runs through the autonomic nervous system. Co-regulation. Another person's calm engagement signals safety to the body. The freeze loosens. The protocol becomes possible. Not everything has to be initiated alone. And 3 conditions where this protocol won't be enough on its own. Active burnout, the empty battery. The system isn't paralyzed, it's depleted, and recovery comes first. Trauma, the cracked heart. The freeze response runs deeper, locked in at a level that grounding alone doesn't reach. Depression, the dark cloud. The flatness here isn't paralysis, but a separate clinical pattern. The clinical guidance is consistent. When these are present, professional support enters. The 3-2-1 protocol doesn't disappear. It becomes one tool among several. Sometimes paralysis is the symptom on the surface of something larger underneath. Brown's clinical work in 2017 maps 3 deeper layers that often present as recurrent paralysis. Burnout, the system genuinely depleted from sustained overload. Trauma, old freeze responses still active in the present. Depression, a flattened motivational system that reads like paralysis but isn't. The iceberg metaphor matters. The visible piece is real. But treating the visible piece alone, when the underlying mass is the actual condition, doesn't change the visible piece for long. A word for the partners, parents, and friends of someone in paralysis. The instinct to motivate, to encourage, to push through, almost always misfires. The phrase "just start" lands as judgment, not support, when the receiving system is in freeze. CHAD's family resources are specific about what does help. Quiet presence. The offer to sit nearby and work on something else. The question, what's the smallest thing that could happen right now? instead of asking why nothing is happening yet. Co-regulation, again. Two hands meeting at the fingertips. That's enough. And to anyone watching this and recognizing the freeze, nothing is broken. Paralysis isn't a character. It isn't laziness. It isn't avoidance. It's the body's oldest defense system firing in a context it wasn't built for. Brown's clinical message has stayed consistent across decades. The brain that freezes deserves the same kindness as the brain that sprints. The ice melts, sometimes faster, sometimes slower. The melting is the body's work. Permission helps. A window. Soft rain. A small light still warm in the room behind the glass. The freeze that arrived this morning may or may not be gone by tonight. Either way, it doesn't define anything permanent. 3, 2, 1. 3 senses, 2 movements, 1 minute. The smallest crack in the ice is enough to start. Until next time, Soft Rain TV.